NASA's James Webb Space Telescope has discovered the coldest interstellar ice mass with complex molecules on it that could one day form the basis of a new generation of planets and stars. The newly discovered ancient ice cloud orbiting the Milky Way is approximately 630 light-years from Earth. Space.com, according to the information provided by, the cloud has an average temperature of -263 degrees Celsius. This makes it the coldest interstellar ice mass ever discovered. The findings were shared in detail in a new study published in Nature Astronomy. Klaus Pontoppidan, a scientist working at the Space Telescope Science Institute in Baltimore as part of the project, made statements on NASA's website. The ices appeared at the bottom of the background, which consisted of a continuum of starlights. In regions that are so cold and dense, most of the starlight from the background is blocked. We needed Webb's excellent sensitivity to detect the lost starlight and therefore the ices in the molecular cloud. The new data is the most detailed analysis ever of an interstellar cloud that could one day merge to form a new generation of planets and stars. While walking through the frozen debris, Webb observed the stars in the background of the landscape to see what wavelengths of infrared starlight, if any, were being absorbed. The team behind the study was able to analyze the light coming from the stars in this way and reveal the presence of a large number of elements frozen in ice. Among them, there are simple molecular components such as methanol, as well as complex ingredients such as ammonia and decarbonyl sulfide. Some of these are thought to be the basic components that a world needs to create an atmosphere for itself. Thus, the probability of the planet being habitable also increases. Our results give us an idea of the stage when ice formation on interstellar dust grains goes through dark chemical stages, turning from disc-shaped planets into centimeter-sized pebbles, explains Melissa McClure from the Leiden Observatory in the Netherlands. These observations open new windows for the formation pathways of simple and complex molecules necessary to create the building blocks of life. The scientists were then also able to estimate the amount of oxygen, nitrogen, hydrogen and countless other contents present in the cloud. The amount of elements turned out to be higher than previously observed in other clouds, but lower than the team expected. According to the researchers, the missing elemental mass may be trapped inside rocks or other sooty materials, which are also found in the interstellar cloud. Since the material in which the elements remain locked up plays a role in determining whether they will form part of an exoplanet's crust or its atmosphere in the future, they will also be important for the evolutionary path of any potential planet that could form from such a cloud. Our identification of complex organic molecules, such as methanol and potentially ethanol, also shows that many stellar and planetary systems that develop in this particular cloud will inherit molecules of highly developed chemical structure, says Will Rocha. He is an astronomer at the Leiden Observatory and is also one of the authors of this new research. This may mean that, more than being a unique feature of our own solar system, the presence of prebiotic molecules in planetary systems is a common consequence of star formation. In the future, scientists will use Webb to try to understand the slow-moving process by which these icy substances are transformed into the structures and atmospheres of distant exoplanets. In the meantime, you can check out the most exclusive images taken by the James Webb Space Telescope here.